Okay, my name is Mel, and I'm going to talk about what is a computer put very simply. Now, most of you probably know, but do a lot of this channel for people who don't, and I'm not going to assume anyone's level of education or ability here. So, computer takes an input of some description, usually from a keyboard and mouse, processes it, stores it, and then outputs something. So, input is anything that lets you give the computer information. So that could be a keyboard, mouse, touchscreen, microphone, or camera. All right. Processing, the brain. This is the CPU. All right. All right. So the processor is the brain that follows instructions. All right. It's the brain. It does calculations. It makes decisions based on logic. So, and then memory. Memory are two types, they're different purposes. RAM, with short-term memory or volatile memory, is fast, temporary, used for things you're doing right now, and clears when the computer turns off. So with RAM or random access memory, once the computer loses power, everything in it will go away. So in general with computers, the more RAM you've got, the better off it does. If you do not have enough RAM, a lot of computer programs and applications will not be able to run. It is just that simple. Now with the CPU, you've got to look at how many cores, and we'll go into that in another video, how many cores and what version it is. The better CPU you've got, the more you're going to be doing with it. So you want a fairly, if you're gaming, you want a fairly high, like a gaming motherboard, you'd have a CPU that's got very high clock rate and throughput speed and stuff like that. Okay, so the more powerful CPU you've got, the better off. And if you don't have a CPU powerful enough, then a lot of programs and stuff won't run either. And like with what's called a server, and we'll go in that another video briefly, they can have motherboards that are called server motherboards that have multiple CPUs. Okay, so with RAM, so we said that there's temporary, and then with other storage, long term, which is solid state drive or hard disk drives. Now, in general, you want both because SSD is a lot faster, and you like for large image files and stuff that needs to be done quickly, you would store on an SSD. HDD could be for backup, and you would also have an external hard drive and cloud for replication of data backups. Okay, so you should. And look, storage holds files, apps, photos, the operating system, and stays when the power turns off. But it does not mean that it can't be damaged or corrupted. All right, so we'll talk about that in another video too. But this is what I'm saying, you should have multiple replications of data, especially if it's important. All right, because otherwise when things happen, and they will with computers, you could lose it. So output, anything the computer shows to you, like be a monitor, speaker, printer. Vibrator motors, such as in controllers or phones. So the computer is a machine that will take anything like input, uses a processor to follow instructions, stores information, and produces output. All right, so this is a computer very, very simply. So look, I'm going to give you an example here of what happens when you open a web browser. Okay, so you click the browser icon. So this could be Microsoft Edge, Google Chrome, Firefox, Safari, it doesn't matter. There's a heap of others. All right, you press the mouse button or tap the icon. The signal travels in through to the computer through the mouse or touchscreen hardware. The processing or the CPU receives the signal and checks what program is linked to this icon. Where is it installed? Where is it stored? Then the CPU sends instructions to load the browser program. Okay, number 3, memory, RAM plus storage working together. Two things happen. The storage, which is a combination of SSD and HDD, The browser program, whether it's Chrome, Edge, Firefox, is saved on your hard drive or solid state drive. The CPU fetches the program files from storage. RAM. The browser is copied into RAM because RAM is fast. It's faster than SSD and HDD. The RAM holds everything the browser needs right now, like tabs, images, scripts, settings. This is why opening many tabs will use more RAM, okay? Then 4, processing again. The CPU starts running the browser's instructions. Draw the window, load your home page, prepare the address bar, connect to the internet if needed. The CPU is constantly following instructions step by step. The output, the graphics card and monitor work together to show the browser window. They show the icon and text and animations, and the speakers will play any sound, and if you've got vibration monitors, will give any other feedback if needed. Okay, so this is what I'm just doing this from bare basics, all right? So now what happens if you type, like if you're going over a network? Okay, so again, like if you type a website and enter, say, google.com, right? The input, your keyboard sends the characters to the computer. The browser now has a full address to work with. So you've just done or example.com, google.com, microsoft.com, who cares? It doesn't matter. Okay, processing. The browser asks, what is the IP address of this website? Because computer talk in numbers, not names. Okay, the DNS, number 3, DNS lookup, still processing and networking. The DNS is like the phone book of the internet. Computer asks a DNS server, what is the IP address of www.example.com or google.com or Microsoft or whatever the website it is you've used. It needs the physical address. So the DNS server will reply with something like 93.184.216.34, which is its street number. That is the physical number that will send you to where you're trying to go. All right. And then number 4, the TCP IP stack gets involved. Now this is networking. I just want to go through this quickly. So the application layer of TCP IP. The browser says, I want the home page use HTTP or HTTPS. Now these are protocols. I would use HTTPS because that's secure. Okay, hypertext transfer protocol if you really have to know that. I'm going to go into this in more detail elsewhere, but this is just like I'm trying to explain the process so you know. Then we've got transport layer, TCP. All right, breaks your request into smaller packets and numbers so they can be reassembled later. Then we've got internet layer, IP. So this is where TCP IP comes in. So TCP breaks your request into simple packets. IP adds the destination address of whatever it was, 93.184.216.34, and your own address. Okay, so it needs the destination and the source. All right, so destination of where you're sending it. All right, and the source. Okay, then we've got network access layer. Your network card turns the data into electrical signals, radio waves, which is Wi-Fi, or light pulses, fiber. Okay, so it can go either over physical cabling, optical cabling, Ethernet, Wi-Fi, all that sort of stuff. Then number 5, the request travels across the internet. The packets move through your router, your internet service provider, multiple switches and routers, and then the destination server. Each device reads the IP header. So the header is what is sent first, right? And that's basically, you need source and destination in your header, amongst other things, right? So it needs to know where it's come from and where it's going to, and forwards the packet closer to the target. The web server receives your request. So the server hosting the website reassembles the packet, processes the request, and prepares the web page data. Then it sends a response back to you using the same TCP/IP layers in reverse. Your computer receives the web page. Your network card collects the packets. TCP reassembles them. The browser interprets the HTML, CSS, and JavaScript, which are all methods you can use to program web pages. The graphic system will then outline the page, right? Draw the page. Output, you see the web page or website appear on your screen, okay? So this is what happens like inside a computer, and this is what happens when you get a website, all right? Where you go to a website. I'm just outlining the basic steps. We'll go into more later.